Lecture 32 covers Section 7.1.
At the end of today's lecture, you should be able to construct and apply our entropy rate balance equation for closed and open systems. Let us recall that for a closed system, our definition of entropy for an internally reversible process is ds is equal to delta Q per T, where ds is our change of entropy, and delta Q is our energy transferred, and T is the boundary at which this energy transfer is occurring. The subscript ReV indicates that this is a reversible process. However, if we have a cycle that contains an irreversible process, our previous equation needs to be modified such that we include sigma, which quantifies the magnitude of our irreversibilities. That is, if we go from state 1 to state 2 via an irreversible process, and then we return from state 2 to state 1 via a reversible process, we are going to have this equal to minus sigma, which quantifies the magnitude of the irreversibilities associated with the cycle. If we insert the definition of entropy for a reversible process into that of a cycle, we can arrive at our entropy rate balance equation for a closed system. That is, as we go from state 1 to state 2 via an irreversible process, plus the difference of entropy between state 2 and state 1 for our reversible process, i.e. S1 less S2, this would be equal to minus sigma. Or we can say our change of entropy between state 2 and state 1 is equal to integral of state 1 to state 2 of delta Q per T evaluated at the boundary temperature for which the heat transfer is occurring, plus sigma. The first term in this expression is the change of entropy between our final and initial states. These are state variables. Our second term is our entropy transfer associated with heat transference. That is our heat being transferred going from state 1 to state 2 per our boundary temperature. And our third term is our entropy produced during our cycle, sigma. If we consider sigma in our entropy rate balance equation for a closed system, we see that if sigma is positive, internal irreversibilities are present. That is, we may have things such as friction. That is, we have entropy produced within our system during the cycle. If sigma is equal to 0, no irreversibilities are present. Lastly, sigma can never be negative.